Alright, welcome to Lecture 6, Polarity. This is just a continuation of our unit on chemical bonding. Polarity is a very important topic or concept in chemistry, and we will be applying it to many applications throughout the remaining part of this year. So you need to make sure that you have this lecture down pretty well packed. The essential questions that need to be answered are: how do you predict if a bond is polar or nonpolar? And how do you predict if a molecule is polar or nonpolar? So these questions will be addressed on the quiz over this lecture, and it's just really important that you can figure out what polar and nonpolar is and predict molecules that are polar and nonpolar. Alright, we're going to start out with looking at what exactly is a polar bond in the first place. Now you can think about that a covalent bond is a sharing of a pair of electrons between two nonmetal atoms. Now that sharing of electrons doesn't mean that there's going to be an equal sharing of those electrons. In fact in many cases there's going to be an unequal sharing of electrons that will occur. What does this mean if there's an unequal sharing of electrons? Well, it simply means that the bonding electrons are simply spending more time with one atom than the other. That means those valence electrons that are being shared are going to be closer to one atom than the other atom. Alright? And when that occurs, we form a polar bond between those two atoms that are sharing an equal sharing of electrons. Right? Now, how do we form a polar bond exactly? Well, what I want you to picture or think about is a tug-of-war match that's occurring between those two nonmetals that are sharing the electrons. The atom that is stronger, or what we would say the atom that has more electronegativity, is going to pull those bonding electrons closer to itself than the atom that has the least electronegativity. Alright? And that tug of war between those valence electrons that are being shared is going to win out, always win out, by the more electronegative atom. Now, if you recall from our earlier lectures, electronegativity is simply the measurement of the attraction of bonding electrons. And different atoms have a different attraction to bonding electrons. And so, if you look at water molecules, for instance, water molecules, the bonds between oxygen and hydrogen, as depicted in this diagram, the oxygen is more electronegative than hydrogen. Because oxygen is more electronegative, the bonding electrons are going to be attracted stronger to the oxygen than the hydrogen. And this is going to create a polar bond between oxygen and hydrogen. Alright? Now, as stated here, the more electronegative atom exerts a greater pulling power on the shared electrons and so gains more possession of the electron pair. So that means in water, which element, oxygen or hydrogen, is going to have more possession of those electron pairs? Well, that would be oxygen because it's more electronegative. So how do we look at representing a polar bond? Well, typically we draw an arrow towards the most electronegative atom, the one that's pulling on the electrons with more force, and we write a line in between like so. And there's another bond here between oxygen and hydrogen, and both of them are pulling towards the oxygen atom. Now, why is this important? Well, because when a polar bond is formed, we form what is called a polar region, or actually two polar regions. And that means that the atom that is most electronegative and gains possession of the electron pairs more is going to create a partial negative charged area. Alright? So, actually I'm only going to write one of these. This sign here that I wrote is called a delta sign. And that delta sign means partial. And so it's going to be only partially negative charged. And so this region up here is going to be negative charged. And that means the hydrogens are going to be partially positive charged. And so down here is going to form a polar region that is partially positive. And so a polar bond creates two polar regions, a partial negative region and a partial positive region. And this is going to have major consequences later on. Alright, so I'm going to erase this and see here. Before we get into question 3 here on polar bonds, let me draw another diagram for you. Let's say we have hydrogen, and it's going to form a covalent bond with fluorine. Now, out of hydrogen and fluorine, which is the most electronegative atom? If you said fluorine, you would be correct. So, which direction would I show an arrow pointing to the most electronegative atom? And that would be fluorine, and it would look like this. I put a line showing that we're dealing with electronegativity. So fluorine is more electronegative than hydrogen, therefore we do have a polar bond. And the electrons are going to be closer to fluorine than they are to hydrogen. So therefore we're going to have basically a polar bond here. So a polar bond. And the more electronegative atom, fluorine, is going to be partially negative, and the hydrogen then is going to be partially positive. And we have our two polar regions in this bond. Alright? So there's an example of a polar bond, and you're going to have to recognize that. You're going to use your electronegativity trend on the periodic table to help you determine if there's a polar bond exists or not. Okay? So what about a nonpolar bond? Well, a nonpolar bond is going to exist only if there's an equal sharing of electrons. An equal sharing. If there's an equal sharing of electrons, then there's going to be no polarity, no partial negative or partial positive that's created. Now this occurs because there's no difference in electronegativities of the bonded atoms. So an example would be between two hydrogen atoms. These two hydrogen atoms are going to have the same electronegativity, so therefore there's going to be no pull, or there's going to be an equal pulling on the electrons, so therefore it results in an equal sharing of electrons, and no polar bond will be formed. Alright? So that's the difference between a polar bond and a nonpolar bond, is the electronegative differences, and an unequal versus an equal sharing of electrons. Also, now what we have to look at is, now that we know what a polar bond is, now we need to look at what about if a molecule is polar or nonpolar. The key to this is these two statements that I have written down here for you, that you need to write down in your notes. And that is, we're going to look at the symmetry along the central atom. With respect to the central atom. So if you have an unsymmetrical, it's unsymmetrical around the central atom. With respect to the electron domains, the molecule is polar. If there's symmetry, if it's symmetrical to the central atom with respect to the domains, then it's going to be nonpolar. So what essentially is that saying? That means if you look at the central atom and the groups that are bonded to the central atom, or in other words, the electron domains are exactly the same, then you're going to have a nonpolar molecule. But if you look at the central atom and the electron domains around the central atom are different from each other, then you're going to have a polar molecule. And so we'll look at some examples of this as we go through here. So the first example is carbon dioxide. Now, if you look at carbon dioxide, carbon is our central atom, and there are 2 electron domains bonded to our central atom, and they are bonding domains. Are they the same? Yes. You have oxygen double bonded to carbon on both of those domains, so it is symmetrical. So therefore, it is going to be nonpolar. So carbon dioxide is considered non-polar molecule. And since it's nonpolar, they will not have a partial negative or a partial positive region within the molecule. But let's look at water. Water's different. Water is going to have 4 electron domains. Remember, if you draw the Lewis structure of water, it's going to have some lone pairs around oxygen, and it's going to have the 2 bonds between the oxygen and the hydrogen. So the question is water symmetrical around the central atom? And the answer is no, it's unsymmetrical. That is because the 4 domains are different. You have 2 bonding domains, and you have 2 unpaired or lone pairs of electrons. And so therefore, water is going to be a polar molecule. Now, if you look at the water being a polar molecule, we've already stated this earlier then, is that up here is going to be slightly negative, and down here where the hydrogens are is going to be slightly positive. And we create our 2 polar regions, like so. Alright? So now let's take a look at some other examples, and you tell me if there's symmetry, being symmetrical around the central atom, or not, and that will determine if it's polar molecule or nonpolar molecule. So let's look at methane, CH4. Right? How many domains around the central atom? There are 4 domains. It's a tetrahedral structure, but is carbon symmetrical? And it is, because you have all 4 electron domains are the same. You have 4 hydrogen bonded to the carbon, and so it's symmetrical. So therefore, methane is non-polar. Right? Now let's try another one. Let's go back up here. I think I have more room. Let's look at modified, let's see. Let's look at a carbon, hydrogen, hydrogen, and another hydrogen, and then a chlorine. Alright? Now, here we also have a tetrahedral molecule. However, do we have a central symmetrical atom? And the answer is no, because chlorine, you have hydrogens, 3 of them, that are the same, but the chlorine is different. So this creates an unsymmetrical central atom, and therefore this is going to be a polar molecule, because it is unsymmetrical. Alright? Where's going to be the negative region is going to be up by the chlorine, because the chlorine is the most electronegative atom. It's going to be partially negative up here, and that means the remaining of the molecule is going to be partially positive. And so you have those polar regions. Let's see, what's another one that we can do? Let's look at something like, let me write out something here. What about, okay, let's look at ammonia. So ammonia is NHH. Alright, so let's take a look at ammonia again. Okay, so you're going to have nitrogen bonded to three hydrogens, and then you have a lone pair. Alright, so nitrogen is our central atom here. The question is nitrogen symmetrical or is it unsymmetrical? Well, if you look closely, you'll see that it should be unsymmetrical because of that lone pair there. So therefore, ammonia, NH3, is going to be a polar molecule. Now, where's going to be the negative region? It's going to be up here by the nitrogen. And why is it going to be negative? Well, because nitrogen is more electronegative than the hydrogens. And so down here, you're going to have your positive region. There. Alright? Okay, so we've got a few examples here for you to think about. So just remember, to determine if a molecule is polar or nonpolar, look at the central atom. If it's symmetrical, that has the same bonding domains around the central atom, then it's going to be nonpolar. But if the central atom is unsymmetrical, having different electron domains around the central atom, then it's going to be essentially polar. Alright? So that's it for this lecture. Go back and relook at your notes. Make sure you come to class prepared to know what a polar and nonpolar molecule is. And that is it for now.